All right, good morning. It is November 1st, 2019. And today you are writing equations of quadratic functions, writing equations of parabolas. That if you have a graphing calculator, you can write those equations and then plug them into your graphing calculator and it will graph it for you to double check that you did it right. And so today we're looking at two different models. We have the vertex form model, which is here, and then the intercepts form, which is if you're given x-intercepts. If you're given x-intercepts, then we get to plug those values in for p and q. If you're given a vertex, then we're going to plug in that vertex point for h and k. So our goal today is to plug in what we know, what we are given. So we're going to plug in what we were given to whatever model we decide to use and solve for A. The A is the thing we aren't going to know, and the A is the thing that we have to figure out. That's what we're starting up with, and then we're going to write the equation. So those are the two basic steps to modeling with quadratics, and it's based on what you're given. So again, if you have a graphing calculator, get it out. You're going to want it. If you have a regular calculator, you're probably going to want that too. But get it out. I can turn the page. That'd be really, really great. Come on. There we go. All right. So here we go. I'm giving you information in two different forms you're going to see today. They're either going to give you a picture with points labeled, so you should draw a little picture just in case with the points labeled, or they're going to give you the information just listed. So I'll write that down. Example 1, write a quadratic function in vertex form. Draw the picture, sure. Write the quadratic function in vertex form for the parabola shown. All right. So in the instructions, they are telling us to use vertex form. But even if they didn't tell me to use vertex form, then I would look at what I was given. Hey, they've given me the vertex. Another clue, I want to use vertex form. On my picture, I can see that the very highest point is also known as the vertex. So they're giving me information, and that information is going to tell me which model to use. So what is our vertex form model? Y equals what? Quantity. What did you just write down for the vertex form model? X minus h, quantity squared, very good, plus k. All right. So this is our model that we're going to start with. And now we're going to plug in everything we know. Well, when they give us the vertex of 1, 3, we're going to plug in those values for h and k. So however they give it to us, if they give us the vertex, those numbers go in place of h and k. So I'm going to write my model. You should write the model. And then we're going to just plug in the 1 for the h and the 3 for the k. I really like doing it this way. Let's keep things straight. And then we have some other information. What other information did they give us? A point. Yeah, they gave us a point. And a point is a lot of information. It's an ordered pair. An ordered pair that stands for what? An X and a Y, right? Okay. So that is information about an X and a Y value. It is a solution. And so whenever they give us the point, we're going to plug that information in for X and Y. So what are we going to plug in for X? -1. What are we going to plug in for Y? -1. So I'm going to plug all of that information in. In place of my X, I'm plugging in a -1. I have a minus in the formula, and then for H, I'm plugging in a 1. And my K value is 3. So I'm plugging in everything I know, and what's left over? What's the only thing we didn't plug in for? A. And so that's going to allow us to solve for A. So we're going to clean this up a little bit. The first thing I need to do is inside the parentheses. What is -1 minus 1? -2. If you're unsure, use your calculator. Then I have to do the exponent. What is -2 times -2? +4. So that is A times 4 plus 3. Well, I don't usually see things written A times 4. I want to change that around. It's more normal to say 4A. And then we're going to isolate A. What should we do first to isolate the A? Subtract 3, subtract 3. What's a -1 and a -3? -4 equals 4A. And then how do we get A by itself? Divide by 4. Divide by 4. So A equals -1. Very good. Is this an equation for a parabola? No, because all equations for parabola should have something squared in it. All right. So I'm going to go back to my model, which was y equals a, x minus h, quantity squared plus k. And you're going to plug in that a, h, and k. So to actually write the model, we have to have an x and a y so that we can graph it on an xy coordinate plane. All right. This doesn't have any x's and y's. We can't graph that. All right. Does that kind of make sense to you? Okay. So we're going to go back to our model, and we're going to plug in the a and the h and the k. So y equals, what do we plug in for a? -1. That's what we just found. -1. X minus, what do we plug in for h? 1. Quantity squared. And then what do we plug in for k? 3. All right. So there is our model that we plug in to our calculator. If you have a graphing calculator, then you can use the cheater's method. The cheater's method is awesome. So if you have a graphing calculator, you're going to go to y equals because our equation says y equals. And you're going to type in exactly what we have here. -1 quantity x minus 1 squared plus 3. The x you're using is right here next to the alpha key. Sorry, you can't see that. Right there next to the alpha key. And then you're going to press graph. And you can see the parabola drawn there. The other thing that's super nice is you can check the ordered pair. So anytime you're given an ordered pair, you're going to use trace. You're going to press trace, and you're going to type in those x values. So type in 1 and hit enter, and it outputs a 3. And it's right there at the vertex, which is very cool. If you type in -1 and hit enter, then it outputs a -1. And again, that's a great way to check your ordered pairs. Okay, it's a very cool thing. let me know if you need help with the graphing on your calculator, okay? That's a cheater's method. On a test, you could totally just do that. Just plug in the equation and check ordered pairs. Having a graphing calculator is very useful. All right, questions on that? All right, let's try one more. Example 2, write the instructions, please. Write the quadratic function in intercept form for the parabola. Write the quadratic function in intercept form for the parabola. Again, they're going to give you two different presentations. One presentation, they're giving you a graph, and the other presentation, they're just listing the information. Write it down both ways so that when you see it in your work, then you'll both ways work. Have they given us a vertex? No, they have not given us a vertex. The vertex is way down here. I don't know what it is. They did not give me a vertex, so I do not use vertex form. Instead, well, apart from the fact that they told me to use intercept form, they're giving me the intercepts. The intercepts are where the function crosses the x-axis. So these are x-intercepts. And they're telling me the intercept occurs when x is 2 and when x is -1. So you can see here our x-intercepts are at -1 on the x-axis and 2 on the x-axis. All right. They've also given us a point, that extra point at 1, -4. All right, so however they give it to us, we're going to take that information. Now, they want intercept form since they've given me intercepts. What's intercept form? Y equals A quantity x minus p and x minus q. The p and the q are the x-intercepts, where it crosses the axis. So one of them is going to be the p, and the other one is going to be the q. P and q. It doesn't matter which one is which. If you wanted to do q and p, that's fine. It doesn't matter. The intercepts are p and q. So what are we going to plug in place of p? -1. And what are we going to plug in place of q? 2. Good. So we've done that. Why did they give us a point? What do we do with that information? X and Y? Yeah, it's an ordered pair. It's information about X and Y. So wherever you have a point, you get to plug that information in for X's and Y's. What should I plug in for the Y? -4 for the X, 1, and for the other X, 1. Absolutely. Plug everything in. -4 equals A quantity 1 minus a -1. 1 minus a -1. Be careful with all of the negatives. And then we have 1 minus the 2. Can you do some cleanup here? What is minus a negative, really? Plus, yes. And could you do that in your head? Yeah, sure, maybe. 1 minus a -1 really becomes 1 plus 1. And again, order of operations, we got to simplify inside the parentheses. 1 plus 1 is 2, and 1 minus 2 is -1. What does it mean when you've got lots of parentheses right next to each other? Multiplication. So we have A times 2 times -1, which is Negative 2a. Very good. 2 times negative 1 is negative 2 times the a. Negative 2a. And then how do you get a by itself? Divide by negative 2. Very good. So we get a equals positive 2. Is that an equation for a problem? No, it is not. An equation has to have x's and y's. So I'm going to go back to my model. Y equals a times x minus p times x minus q. And what do you think we're going to plug in for this one? What do we need to plug in to write the model? What do we solve for? A. A and P and Q. That's very good. We need the X and the Y to graph it. All right. We plug in everything else. So in place of the A, we're going to plug in a 2. And then we're going to have X minus, what do we plug in for the P? Negative 1. And then what do we plug in for the Q? X minus 2. And I can clean up just a little bit. 2 quantity X minus a negative is really plus 1. And X minus 2. So there's my wee little equation right there that I ran out of room for. Sorry about that. There we go. And again, if you wanted to plug that into your calculator, into y equals, you can plug it in and then also check these ordered pairs that are there. All right. Do you have questions for me? Awesome. You should have no trouble finishing this assignment today. I also want you to know there will be an extra credit posted soon for this weekend in the class website, student view under Good Now and announcements.